Chi-square test of independence. Session prerequisites. Browse to our earlier material on independence of variables. In preparation, please have the spreadsheet open on your computer and follow along. Maximum benefit guaranteed. Learning objective. Establish independence of variables within a dataset.
Let's get back to the two tables. We have observed counts versus expected counts. What we need is to know how far 96 is from the expected count of 92. Well, of course it is 4, but it is 4 as a proportion of 92 versus, let's say, 6923 versus 6951. Yes, the difference is 28, but as a proportion of 6951, it is far less. Now, what we should be looking at is the squares of the deviations. These deviations are large if the count itself is large. So, we will divide by the expected cell count. So, I have this shell of a table here where I'll populate it with the observed count minus the expected count, square the deviation, divide by the expected count. I will go ahead and populate everything and drag it down, and I'll also sum up everything in the column over here, drag it across, sum up everything in the row, and when I sum these things on the margin, I get 3.403. If the deviations in counts were sizable, this total would have become large. The question is, how large must this total be before we declare that the variables are not independent? To resolve this, we must understand the chi-squared variable. Suppose that z1 through zn are all standard normal variables with the property that they are independent. Then the sum of squares z1 squared through zn squared, call it x, follows a chi-squared distribution with n degrees of freedom. The densities are as you can see here. This distribution has parameters that are very easy to remember. The expectation is n and the variance is 2n.
Really? Even I can remember that.
Back to our table here, we have 4 categories for race and 2 for gender. So the degrees of freedom turn out to be row minus 1 times column minus 1, which is 2 minus 1 times 4 minus 1, which is simply 3. We'll talk about confidence levels in lots of detail during the next course in our Statistics for Business series. For now, we'll assume a confidence level of 95%, which translates to a significance level of 0.05 or 5%. Here's a picture that shows how we arrive at the critical limit that we are talking about. Here's a litmus test. If the sum total in this table falls below the critical value of 7.814, then we declare that the race variable is independent of gender.
It's that simple?
You can guess the exercise I have in mind. Add in the race that we had deselected earlier and go over all the steps we took. What do you expect to see? This has been our first encounter with a statistical test. Numbers in business settings rarely follow precise patterns. We can detect general trends like with our census data. Being quant types, we must support statements we make with a rigorous argument. Statistics supplies the necessary tools for us to draw conclusions beyond reasonable doubt.
Or statistical doubt.
More like it, that's right. So now you go out, try the exercises on your own.
Stay independent. Peace out.